Another part of the syllabus is about doing homework and meeting expectations. And you should read this page of the syllabus thoroughly and think about the questions that are posed there. I'm trying to lay that into context with the things that you know you need to do. Certainly you know you need to do homework, and these are some of the activities that you should be practicing in your homework. Exercises, reading, and planning ahead, being prepared for the next class. How much time should you spend doing that? Well, the college says that for a course at Franklin and Marshall, you should spend about 3 hours studying for every hour in class. And so I think that this class is probably consistent with the expectations that are laid out by the college. The kind of thinking that you want to be able to do in this class is higher level thinking skills. We're certainly going to be learning at the lower and practicing at the lower end of Bloom's taxonomy. You can look up Bloom's taxonomy and think about it, but these are lower level thinking skills. We want to be operating sometimes, as much as possible, up here and developing these skills. And I've highlighted a few words that describe some of those higher level thinking skills. You'll see original work, appraising, judging, and experimenting are higher level thinking skills in Bloom's taxonomy. That's where we want to try to go. And so, in order to get a B in this class, originality and insight are two of the things that you have to practice according to the college's description of the grading system. So I expect you to be able to do those things at higher level in order to achieve a B or an A in this class. This is just consistent with the other organic chemistry courses here at Franklin and Marshall College, and frankly across the country. So let's imagine in context what some of those thinking skills mean. So imagine you had general chemistry and you learned about the kinetic molecular theory of gases. So you learned here, these are some things that we assume might be true, and on that basis, how would gases behave? So you would have then figured out that, oh, pressure and temperature have a relationship, pressure and volume have a relationship, moles and pressure, these things have relationships. And so some of those are outlined in equations. And so you would have then practiced using those equations. So perhaps in class you might have had a question where you were laid out with a set of conditions and you're told, hey, the conditions are changed, and so what's the new pressure? And so you would have used some equation to determine what that new pressure would happen to be. And so what you're practicing there is the relationship between the variables and the behaviors of gases. So in homework, maybe you had 5 or 10 questions like this where you're given a set of conditions and then you're told that the conditions change. And so what's the new volume? What's the new temperature? What's the new pressure? What's the new number of moles? Those are the variables, and you would be solving for one of those variables. So when you get to an exam, perhaps you're asked a question that's just like that. That is not a problem. That's more like an exercise. You are being asked to do something that you have already done before. I'm not going to refer to that as a problem. I'll refer to that as an exercise when you're given that as part of homework. So you might also, however, be asked, hey, what happens if we deviate from our expectation? So if I have a mole of a gas is compressed to half its volume at constant temperature, and we find that the pressure is more than twice. That's not what we expect. If the volume is half, we expect the pressure to be twice, but this pressure is less than twice. Why is that? This is not a quantitative question, and we're going to have to demonstrate something about our understanding of how gases behave in order to answer this question. This requires a little bit of insight. We might also be asked, what happens if we take 2 gases and combine them and they take up less volume than we expect? This might require some creativity. We might have to take what our understanding of gases is and expand on that understanding on the spot to answer that question. That's going to require some creativity in thinking about the concepts. And those are things that you're going to have to be able to do in order to get a B in this class on occasion. So you might want to think about where these things lay on Bloom's taxonomy and how it relates to the page in the syllabus to which I'm directing you. Now I want to assure you that you can do this. I've seen hundreds of students and they do this. You can do it too. One of the things that you might be useful to you is to think about Bloom's taxonomy as you go through the material and ask yourself, assess yourself, where do I stand in my understanding of this material according to Bloom's taxonomy. Thinking about where you are in your learning is called metacognition, and just practicing metacognition helps you learn better. So if you practice metacognition, I believe you can do just about anything you're asked to do this semester.